G'day. I have a bad habit in my shed of putting things down on the bench and then gradually over the years accumulating, and so I got to the end of this year and started to go through some of these things thinking I should really finish some projects off, and I discovered the Taylor Hobson rotary table thingy, which needed a few small parts to be made but was basically right for completion. So over the last couple of days I've done that. A couple of things to notice here. First of all, if you look at the angle that table can incline, and then you look at the angle here, right, that's at full push. I can't get any further, and that's at full push. Comparing the castings, that's a lot shallower. It's allowing that to clear. So I'm going to have to get in there with the angle grinder and clean that up, and that's one good reason for proving castings, is you discover things like that. So I'll get in there and clean that up and get myself a bit more travel. I want to put this slot in here. Now, I've measured that with some feeler gauges, and that's 0.8 of a millimetre thick, or sorry, wide. I was trying to work out how to do that, and then I realised that, well, a standard hacksaw blade is around 0.6 of a millimetre wide, and so if I put two of those in my frame, as you do when you're making screwdriver slots, and cut through there, that shouldn't take too long, and that'll give me a good enough slot there, I think, and then I can go ahead and drill and tap the hole there and bend up my handle so I've got the clamping device worked out. I've put my slot through over there. I've got my table, put that in there, nut. I've got a clamp just to hold it in case it wants to tip on me. And I've got some vice grips on my knob. There's a little bit of a tight spot in there, and I think it's basically the shaft that I've got on the end of this knob is not quite concentric with the thread. I've got that round to a point where I've got that locked up, and so I'm going to put a mark in with chalk on the outside of the bend. Get the torch out, heat that up, bend it over, and then I should, fingers crossed, have a locking mechanism for the table here. I mentioned a little bit of stiffness when I tried locking this up before. I put some marker pen on there and threaded that down. As you can see, it goes, reasonably well at the moment. So that's locked and then out again. And what I discovered was that basically I had pen missing off there. Now, if ever you're putting a thread together and it's cyclically easy and then hard, the same point in rotation, it means that something's bent. And in this case, I found there's a slight bend in here, so I've put that in the vise, gave that a swat with a hammer a couple of times, and it's fixed it. If that was a high spot on a nut, I'd expect to see a helical pattern around there, but because it's all on one side, it means that the shaft is bent with relative to the thread, and so that's what's caused my problem. But while I also had this part, I've put the chamfer on there and there as per the original. There'll be a 0 mark on there somewhere. The way you index on this, if you want to index in fixed increments, is that there's a disc with 2 holes in it that just slips over there like that. And then there's a collar with 2 pins on it. Now this one's a little bit worse for wear, so I've made up a new one of those, just as a bit of a thank you for Crine, whose bit of equipment it is, and that should locate on those like that. And then the duck sort of locates in these notches. I made up the collar some time ago. I haven't got the holes in there, and I also need to make up an indexing disc. I'll leave that plain for the moment because I'm not quite sure what I want to index in, probably 15 degrees, but I might make up another one. But then it's a matter of putting the holes in to locate in that. This is a little tight. This is the problem sometimes with rings. If you cut them, they can sometimes spring in, they can sometimes spring out, depends on what the stress is. And so it's one of those things that I was expecting that I was going to have to do something like this. I've got a bit of shim, which is the width of that cut with the bolt relaxed. I've put that in there and then tightened it up. And so what I'm hoping is that basically that will be the natural position of the ring. I'm then going to have to come in here and pick up the inside of that, and I'll probably do that with the optical microscope, but I'll also probably run around there with an indicator or something like that just to check. Then it's a matter of setting the boring head up just to take the ever so slight, smallest pass off there. I've marked the inside of the bores here with some texture just so I can see where it's coming off. I'm quite expecting that it'll come off in one area and not another. If you can imagine, you've got a ring, it's closed up slightly, the cut is there, so I'd expect that the difference is basically in here. I'm ready to do the second ring. The first ring went pretty much to plan. These are two 3/16 holes, and they're there for the locating pins, which then match up with the indexing plate. I haven't made any of these indexing plates yet. Long boring bar here, just so that I ensure I clear the clamps. I bring it down and I touch on the inside, run it around by hand just to see how much of the texture is scraped off, and then bore it. And I think I took out something like 0.1 or 0.2 on diameter on this one. So there's not much. Probably in hindsight, it was one of those things I should have left a little bit more undersize, so that when this happened, I could, bore it out with a little bit more leeway. You may not be able to see very well here, but this is the first pass, and I've got the texture is pretty much scraped off here, but around here, I've still got some marker. So just the act of cutting through that slot has distorted this slightly, and so I'll need to do another pass or two. To hold the indexing wheel in place, there's a couple of holes in it, and then there's a couple of tapered pins on the, what do you call it, the clamp block or something, I guess, clamp sleeve. Now, they locate in there like that, not a problem. I need to recreate that. These are 3/16, and on mine I've made those 5mm because I've got some 5mm dowels. Now I managed to put a taper on that, and it's a bit of a bodge, but it works, so I'll show it to you. What I've basically done was got the masking tape and marked where I wanted the taper to start. I've then put that into an electric drill, turned on the grinding wheel, the bench grinder, and just taken that down to size, and then I've come along with a finer wheel to take out the heavy scratches, and that's given me quite a reasonable result. Two small parts that I've made up and haven't mentioned to date. One is the pin here. Nothing terribly exciting about that. It's a cylindrical pin with a chamfer on it and two flats on it. And the other part is the spring that fits inside the duck here. Now that goes in there and screws on. What I have discovered is that there's a difference between this one with the spring, and I've only just made up the springs, I've only discovered this, and this one with the spring. And so I need to make that slot just a smidge deeper, maybe a millimetre deeper, just so that that spring will bear properly on that flat, because that's what keeps the duck, pointing in. That's a little bit better. What I did was I put a couple of packers either side, plus a 1mm one on this side, and then put a parallel or straight edge across the top there. And what that effectively did was kick this end up a millimetre higher, and then I could zero on this surface and go through and take that off. Now what that does is just brings the spring a little bit closer, and so you can push the spring on like that, but then when you rotate around to get to the flats on the side of this post, it acts as a spring retainer. Okay, if you want to get that off, you just have to turn it round till it's not in one of those slots, and then you can pull it off. So it's quite a clever little design feature. Here are the two bases. Now I mentioned previously that when I sat the swivelly bit on here, it was not going full travel, and so I've marked where it hits. I've got a profile gauge here. These are used mainly by people in the tiling trade, but I got this one because I do a bit of wood carving, and it helped to try and match sides up. But what I find is when I put that on there, and then I put that on the same sort of location there, I've got a bit of a hollow just there. So what I've got to do is get the angle grinder out and relieve this area here. I put some tape down and put some lines on it, basically measured back from the corner there to work out what the profile was with the profile gauge, and then put some lines on the casting here to sort of compare. Pretty much the last thing that I have to do is put in the stop pins. These are located at the end here, and there's one per angular position, but if you could imagine them sitting in place without the casting, they sit like that, and there's a bit of rotation there, so you can actually adjust the stop position. And so there's one here for 0 degrees, and then there's another one here for 90 degrees. To lock these in place, there's I guess you'd call it a screw with a cutout in it, and you tighten the nut up that sits in that recess, and that pulls up and locks that in place, a bit like a cotter lock really. I'm setting up to do the 2 holes in the top here, and I've decided I'm going to split the difference and make them 5.5, and that'll give me a little bit to play with when I machine away. I'm doing this by my favourite method of level here, and when they're equal, it's all set up. I've already squared the back to the column of the mill, so it's really just a matter of positioning and drilling. To drill through on this hole, I just squared this up on the table. To put this one here, I used the level once again, level on here, and that should be horizontal. And I've just drilled through using a hand drill. There and there are the marks where I drilled through. So I can just come in with an end mill and clear up to the side of that, clear down to the top of that, and that'll get me pretty much where I need to be. And then that's basically that bit done. I can then drill those holes out a little bit bigger, make up the stepped pins, and make up the locking pins. Just at the tip of the scriber there is the witness mark left by the drill. So I'm just creeping up on that, and I've probably got 0.1, 0.2 to feed across. I've already done the one up here, so I'll just smooth that out with a file or something like that, but that should give me a good surface to adjust my stop against. I'm setting up here to drill the 2 holes to act as the clamping points, but I thought I'd show you this setup because this shows how convoluted some of these things can get, and it's a sort of it's the reason that I have 1, 2, 3 blocks and jacks and all that sort of thing, is to be able to do this sort of thing. So because those holes need to be positioned off the axis of that hole there, and the same over here, I've got a gauge pin, snug fitting gauge pin, put that in there. I've then got a square which I've then put up against there, and that way I can work out where the outside of that pin is and the outside of this pin, and so then I can get a centre and I can work out where those holes should be. I've also got that edge lined up so that I know that as I come across in the X, I've got everything parallel. The end result is that I'm going to be able to drill those holes there and put in my cam pins, and then come in and drill these out to the final size, and fingers crossed everything will line up. These are the last two pieces. That's the eccentric stop, and as you saw, that's just done in a 4-jaw chuck, kicked over, and very carefully, because I made this out of stainless, very carefully with the parting tool, took that out, and then slotted the end with a slitting saw. And these are the locks which sit on there and then pull up. And these actually started life as a socket head cap screw. So I cut the head off, left the thread long so I had something to hang on to. There's the stop fitted. The clamp bolt sits underneath the table when it's on, which is a nice little feature. I was surprised how effective that was. I was there and turning it with a screwdriver just to adjust it, and got, I had the level on top, and I was getting a graduation of movement which was something like 45 minutes just for a slight turn, so it is quite effective. But there you go. So Taylor Hobson rotary table finally finished, except for a few minor bits and pieces. I've still got to number the scale graduations here. That's either going to be extremely straightforward, and you've seen it all before, or it's going to be fiendishly difficult, in which case I'll have to do another video on that, but that hasn't been done. I need to strip the thing down and paint it so that it doesn't go rusty. The other thing is I've got a blank disc in there, but I need to put some notches on there, but that's once again very, very straightforward, very easy. So there we go. So thanks for watching, and we'll see you for the next one.